How's everyone doing? I'm going to be doing the 60-degree inclination angle for the project 2. So I'm going to open up Fluent and a new one. The geometry, make sure it's 2D. And we'll open up a new design modeler. So we'll wait for that to load. All right, so now let's change our units to centimeters because that's what we're going to be working with for this part. X-plane and start sketching. Zoom in a bit and then start with a 3-point rectangle. And try to get this on the origin. All right, so I think it's on the origin. Next we're gonna do some dimensions. So it's gonna be 0.1 centimeters. It's gonna be 30. Yep, 30 centimeters for the length. And then I'll just do the inclination angle really quick. The angle, click the horizontal, then click the top plate. Top. So we can let's try that again. Angle. All right. So for 60 degrees, it'll be 120, I believe. And then we'll zoom out. Everything's good so far. We're going to make the boundary layer, so we'll fix that. The dimensions, 6, 7. So we want this to be 500 centimeters. P8, 250, you want it to be in the middle. And then page 6 is also 500. And then one more dimension. H9 will also be 250. So now we have this nice big boundary layer for our 60-degree plate. If you scroll in, it's our plate. And so now everything looks good. Go back to modeling, click on our sketch, and then concept, surfaces from sketch, and apply, and then generate. So now we have the boundary layer. And if we zoom in, we should have, yep, we have that space right there. So now this is good. We can go over to mesh. And I'll start with the meshing. Hopefully it opens. Cool. So now, well, this is design modeling. Here's meshing. All right, so we'll start with mesh. So we'll do standard mesh. And now we're going to go ahead and inflate. We'll get in here and then Make sure you're on line select. Control Shift. To select multiple parts. Y. Oh, that's great. Then do it again. I don't really know a better way. Rather than drag it across for 20 years. One second. Here at mesh, sizing, turn off mesh defeaturing. Go ahead and generate that again. All right, back to mesh. Mesh defeaturing doesn't generate. All right, I'm just gonna delete. No, generate. Okay, there we go. And now we can inflate. First, let's just rename it all, or not rename it, but just name it all. So here, let's enter the shortcut. Front plate. Bottom plate. And rear plate. Let's go all the way out, and we'll do Control Shift is top and bottom. Name them symmetry, or just sim. And inlet and outlet. All right, now we have all these named. Cool. And now we'll do some inflation, I believe. And then the boundary is going to be the faces of the plate. Apply, we have 4. We're going to do 5 layers and generate. And there we go. And now we're going to do a triangles method. And generate that. And now we'll do some sizing. I'm going to get back into the mesh, still allow scrolling. But remember, control, click, 4 edges. And for this size, we're going to do 1 to the -3. And then curvature, turn it off, make it hard. And then go ahead and generate. Zoom out. And we'll make another sizing. And do the inlet and the outlet. Apply. On the size, we're going to do 1 to the E -2. No, that's hard. And generate. Wait for that to finish up. All right, looking good now. So let's actually just make this 0.1 and generate. Yeah, there you go. So now let's close out of design modeler. And save. And now we're going to update. Now we'll go into mesh, full precision. I run 4, just so it runs a bit faster for the processors. And we'll wait a bit for it to load up. All right. All right, everything's in. Go to models for viscous model, K epsilon. Make sure you hit enhanced wall treatment and pressure gradient effects. Looks good. Okay. For the materials, fluids, and then air, where you have to change it to tendency to just 1.2, and then viscosity is 1.8 pascals a second, which is the same as kilograms over meters times a second. So change create, close, go ahead and check the boundaries, inlet. You want to do it for 15 meters a second. Apply back. Outlet, pressure outlet, and then everything else should just be a wall. Yep. All right, so now we'll go to reference values. Length will be 0.3, and area will also be 0.3. If you're just multiplying it by the depth. And then compute from inlet, reference zone, surface body, and then go ahead and change the residuals. Where is it? Here it is. The residuals, and change these to 1 to the E -6, and just copy it for all of them. Okay. And now we'll go to, let me just check, make sure that's still good. Yep. Initialization. Wait, and before we do that, the methods, simple, presto, and burst order upwind. Cool. And now let's go to initialization. I hope it doesn't crash. Let's hope it doesn't crash. All right, cool. Initialize it. Initialize, converged. So now we're all set to run calculations. We're going to go to 1500 intervals or iterations and go ahead and calculate. And once again, hope it doesn't crash. That's just half a fluid. All right. Oh, all right. Now it's running. We'll just wait for this to run. 60 degrees, it was a little less, I believe. I don't really remember how many iterations it took, but it converges at some point before the 1500. All right, so it's almost done. So yeah, 1297, it converged. Hopefully it will also respond. Cool. So it's converged, and now we can go ahead, go to reports, forces, select them all, print, and this gives you all of the forces for the drag, so pressure, viscous, and total forces, and we use all this to find the coefficients in an Excel spreadsheet, and then use that for your report. And then you can check the contours here, but I don't like the contours here. I'm just going to do it in post. So let's close out the mesh, just run things a bit faster. Go ahead and go to results, open that up. So we need the vector, velocity vector, velocity contour, pressure contour. So we'll start with pressure contour. Make sure you're on symmetry 1 and just pressure and 750 number of contours. Just apply. And that looks good. High pressure and low pressure for 60 degree makes sense. So we'll go ahead and unselect that and make the velocity one now. Same thing, symmetry 1, and then just velocity. And then same thing, 750 for the number of contours, and apply. And this also looks good. The wake region and the turbulent flow following the plate. And then for the vectors, you're going to do these arrows, vector, velocity vector, same thing, symmetry 1, and just apply. And here you'll see the vectors for the flat plate. If you zoom in a lot, you'll see the individual vectors. Here's the turbulent flow, with the low pressure getting sucked in. And then here are all the vectors itself, and then plate's very thin, so it's hard to see, but if you keep zooming in, you'll see it there. But yeah, so that's how you find the vectors. And then if you go to Fluent, plots, XY plots, wall fluxes, X shear stress, and then the top plate into curved length plate. All right, just direction vector, I guess. And then here's the top plate with the shear stress. And so that's how you get all this. I believe that's everything for the project. As you see here, you get the contours, you get the drag forces, drag coefficients, all stuff like that. And I believe that is all that is necessary in terms of the Fluent aspect. So yeah, that is the end of this video. And then if I go ahead and click out post or Fluent, and post. And then you can just, what is it? Duplicate and just do that all the way down for each case. And that's it. So yeah.